This is Josh White with JW Math Tutoring, and this video is going to show you calculator hacks that you can use to solve SAT math problems entirely on a graphing calculator. Obviously, these are going to be used solely on the calculator section of the SAT, and I'm going to be demonstrating these with the TI-84 plus C model graphing calculator. Now, a couple things to be aware of. First, I'm going to go through the operations themselves fairly quickly. So if you're not familiar with the operations that I'm using in this video, please check out a previous video that I've made regarding the ACT, where I go through these specific operations in much greater detail and have the specific steps listed on the screen. So you can kind of like follow along and look on the screen as well. Also, you can download a PDF file which will have the specific directions for these operations and how to perform them on the graphing calculator. The link for that will be in the description, of the video below. So, with that being said, let's go ahead and get started. This is going to be, by the way, part 1 of the calculator hacks for SAT math problems video, and there will be a part 2 to follow up as well.
But life is a dream the calculus could never predict.
So now let's go ahead and take a look at how a graphing calculator can help you solve problems on the calculator section of the SAT math test. So I am going to demonstrate these on a TI-84 plus C edition. Obviously, if you have a TI-84 plus or TI-84 plus CE, most of these operations that I use are going to be identical. Similarly, on a TI-83 plus, most of them will be similar, but there are a couple that are slightly different. For example, the process of using matrices, which I'll get to later, is a bit more complicated on that. If you have a different brand graphing calculator, that's fine. What you should take away from this are the types of problems and types of operations that you can do on a graphing calculator to solve these problems almost entirely on the calculator. So I'm going to start off. This first one is from practice test number 1, the 10 tests that the College Board has released, although technically it's now 8 because they pulled practice tests 2 and 4. It's problem number 25. And you're basically asked to find, after how many seconds will a ball hit the ground in this scenario. So here, you do have to know that when the ball hits the ground, that its height is just 0. So now what we're going to do is basically go and graph this function and then find the x-intercepts or the zeros of it, and one of those is going to be our answer. So I'm just going to go to the y equals screen. I'm going to enter in my function to graph, except I'm going to use x instead of t. So it's negative 4.9x squared plus 25x. We'll go ahead, we'll graph that out. Shouldn't need to change my viewing window since all these values here are between 3.5 and 5. Okay, so we're now looking for the values where the height is 0, or in other words, the y value is 0. So one of them is obviously right here at the origin. That's not the one we want. That's before the ball actually leaves the ground and goes up and then comes back down. We want this one, right over here. So all we have to do is go second trace and then go to 0. Okay, now it asks for left bound. So I'm just going to have to move my arrow over here a bunch of times. Eventually it'll show up again. Okay, so just as long as I'm to the left of my 0, that's fine. I'll hit enter. Then for the right bound, I'll just move below my 0 to the right, hit enter. Now for my guess, just get as close as possible. Okay, now it comes back as 5.1020408. So notice that is not not an exact value relative to the answers, but it says in the question after approximately how many seconds. So 5.1 is just going to be equal to approximately 5 seconds. So the correct answer for this problem is just going to be letter D. Did the entire problem again on the calculator, just using the 0 function once we graphed it. next problem we're going to take a look at, we're going to use the same function. It's from the May 2022 QAS that was just released a little while ago. It's problem number 33, and here you're given an expression. And it tells you that one of the factors is whatever, x plus b, where b is a positive constant, and it asks for what's the value of b. So we can actually do the exact same process where we graph this function out and then we look for its zeros, or where it crosses the x-axis. Because if an expression is a factor of, basically of a larger expression, or of not really of an equation, but basically if we have some smaller expression which is a factor of something else, then that means that will give us a zero or a root of that larger expression, or say of that larger equation. So I'll just go back to y equals, I will type in 2x to the third plus 14x squared plus 24x. Let's just make sure that matches. Okay, yes. So now we'll go ahead and graph that function out. Okay, so notice it's asking for b, where b is a positive constant. So that means, and here's what you have to be aware of. If you took this expression, okay, and you factored it, and you had something like, just hypothetically whatever, x plus 2 times x plus 4 times whatever, there'd be another parentheses here. Technically, those would give you zeros, or roots of -2 and -4, because you set each expression, you set each factor equal to 0, and then you solve it. So when x plus b is, so we have an parentheses of x plus b here. Okay, if b is positive, so this is some positive number, that means the 0, or the root that we're looking for, is going to be negative. So these two negative values over here, either one of them are going to be acceptable possible answers. So we can just go back to the calculate menu. We can go to 0. Let's look at the one on the right first. So for my left bound, I need to get to the left of it. For my right bound, get to the right of it. And now just for a guess in between. Okay, so we have one possible value of -3. That's our 0, or our root. Now we're going to take a look at the other one. So now I'm going to check the one on the left here. So for the left bound, I'll move to the left of it. For the right bound, here, and then in the middle for the guess. Okay, we get -4. So these are the roots, or these are the zeros. That means that the actual values of b are going to be +3 or +4. Essentially, the parentheses, if you factor it, would be x plus 3 and x plus 4. Then if you set each of them equal to 0, you would get -3 and -4, which is what the calculator gave us. So correct answers to this problem, there's two of them. +3 is one, and +4 is the other. And again, we did the whole problem on the graphing calculator. Next up, we're going to look at finding the maximum or minimum value of a function. This is from practice test number 4. It's problem number 28. And here you're basically given a quadratic function, but it's an intercept form. It is not in vertex form or standard form, which the answers are in. And so it says which of these answers basically has the minimum value of this function as a constant or coefficient. So that means these number terms right here, okay, which of these is going to be the minimum value for this function? So what do we do is we can go ahead and there's we can just graph out x plus 6 and then x minus 4. Okay, I can't actually see the minimum value, so I'm just going to zoom out. Just move down here, just zoom out to get a better view of it. Okay, so now I can see it. Now we'll go to second, calculate. We will go to minimum. Left bound, we'll just move to the left of it, hit enter. Now for the right bound, to the right. Now for my guess, just right in the middle. Okay, so the minimum is going to be at negative 25 for the y value, because when we're concerned about the minimum value of the function, what we mean is the minimum value of the output variable, or in this case of the y. So the minimum right here it gave us, we want the y value, it's negative 25. So that means the correct answer for this one is going to be letter D. And that's it. We don't need to do anything else. We're just matching up right here which of these has a negative 25 as a number in it, and D is the only one that does that. All right, moving on to the next problem. This is from practice test 10. This is problem number 36. And in this one, we're going to use basically the same kind of same function, same idea, maximum or minimum value of a function. So what happens here is you have a parabola, and you have a line that's intersecting it at only one point. And basically the line is horizontal, it's y equals a number, and you want to know what's the value of that number. So all we have to do is just graph the parabola, negative x squared plus 5x, quadratic function. Okay, once we actually, we'll go to the standard window size for the zoom, so it's a little easier to see. Okay, so hopefully you notice the only way that a line, specifically a horizontal line, can intersect this quadratic function or quadratic graph is right at the top here at its maximum point, or in other words, at its vertex. Any other horizontal line, that is not at the vertex is basically going to intersect it twice. Once on the left and once on the right. So what we need is the y coordinate value of this vertex, which is the maximum of the function, and that'll basically be the value of c. That'll tell us where the horizontal line is that intersects it once. It's whatever is up here that goes through this point. So we just go back to the calculate menu. We can now do a maximum function. Left bound here is fine. Right bound, we're just going to have to go over to the right of it. Hit enter, and now for guess, we'll just go in the middle. Okay, so again, here we're only concerned with the y value. So the y value is 6.25. So that means that is the value for C. So you could input that as 6.25, or you could grid it in as its fractional equivalent. And so we could just go out to the home screen, and we could type 6.25 and then math frac option 1. Okay, so you could also grid it in as 25 division sign 4. So that's the value for C, y equals 6.25, y equals 25/4. That's a horizontal line that intersects this parabola, this quadratic function at only one point, specifically the vertex of it. All right, next let's look at another problem involving basically the intersection of two functions and how we can actually use the intersect function, the calculator, to get our answer. So this is from practice test number 7. It's problem number 35, and it wants to know what ordered pair satisfies this system of equations. So all we have to do is just graph out both of these equations. One, again, is a quadratic function, or a parabola. The other is going to be a line, 4 minus x, and let me just make sure that this draws a line and not an inequality. Okay, so now we can go ahead and graph those functions out. Okay, so notice there are two intersection points on the graph. So we only need one possible value of x, but we'll just go ahead and find both of them. So we're going to go to the calculate menu, then intersect. Okay, so the first curve, we're on the blue one here, which is the parabola. The next one, we are on the line, which is the red. And now for a guess, we'll just get as close as possible. We'll hit enter. And notice it's like an extremely small number. It's 2.427 times 10 to the negative 14th. It's really 0. Okay? So occasionally, just because of rounding or whatever, the calculator doesn't give you like the exact value, but one possible answer is 0. You can also confirm this just by spot checking it, by looking at the equations here. When you plug in 0, you get 4 for both on y. Or you could also go to the table values and notice that when you go to 0 down here for x, notice they are both equal to 4. So that's just another way to get it. Now to find the other possible answer, which is right down here, we'll go back to the calculate menu. We will go down to intersect. The first curve is still the blue one. The second curve is still the red one. So I just hit enter. Now for guess, I'll just move closer, down to this point. So I'll go ahead and hit enter, and now it gives me an x value of 3. So there are two possible answers for this problem. 0 is one of them, and positive 3 is the other. Again, the entire problem done on the calculator, in really not that much time. The next problem is from practice test number 6. It's problem number 34. And so what's going on here is, again, we have two different functions that are intersecting. So the first one is going to be 3x squared minus, and rather than just delete the whole thing, I'll just insert some digits as needed, minus 14x. Okay, now I can delete. And the second one is just y equals x. And it says they intersect at 0, 0, and AA. So basically, again, these are going to intersect at 2 points, just like the last one. One of them should be the origin. That one we're not concerned with. It's the other point of intersection that we're trying to find. So this is the origin. That's 0, 0. They already give us that. That's not what we want. This one over here, that is the one that we're going to get from the calculator. So let's go to, again, the intersect function. First curve is my blue one, my parabola quadratic function. Second curve is my red one, or my line. Hit enter, and now for the third one, or not for the third one, for the guess, just slide over here. It actually looks like, we can see it because it just happened to land right on it. It looks like it's going to be 5, 5. I hit enter, and yep, that's it. So what's the value of a? It's just 5, because the point that it gives us back is 5, 5. So correct answer for this one is just 5, and that's it. Now, the last problem I'm going to show on this first video, and don't worry, the second one will be coming out shortly with even more problems, is how to solve a system of equation using matrix properties. So in this problem, it's from the October 2021 test, it's problem number 34. You're given a system of equations, but notice both equations are in standard form. They are not in slope-intercept form or y equals form like all the previous problems were, where it was very easy to just enter the graphs in right away. We didn't have to do any rearranging or any work. However, this one, if you wanted to use the intersect function, you would have to take the first one and you'd have to rearrange it and solve for y, and you'd have to do the same with the second one. And that work isn't necessarily that difficult, but still, it's just, takes more time, takes more effort, more chances to make a mistake. So instead, we're going to show you how to solve this just entirely on the graphing calculator. And then after we do that, we're going to take x plus 2y and get our answer. So we'll quit out to the home screen. Let's just clear this. First thing we need to do is we need to bring up a 2 by 2 matrix. So we'll go ahead and select that, and then go down to OK. And then inside here, I am going to put the coefficients that are on the x and y terms. So it's basically going to be 3, 4, 2, 2. Now after that, I'm going to do the x to the negative first power. Now I'm going to create another matrix, but this one's going to be 2 rows by 1 column. And once I have that on the screen, then I'm going to basically enter in these two values on the right, 35 on top, 15 on bottom. Now I just move all the way out to the right, go ahead, hit enter. Okay, so there is my answer. So x is equal to negative 5, y is equal to 12.5. So now for x plus 2y, I'm just going to do negative 5 plus 2 times 12.5, hit enter, and I get 20. So final correct answer to this one is 20. Again, the entire thing is done on the calculator, pretty much without needing to write anything down by hand. So I hope you enjoyed the first part of this, SAT Math calculator hacks video. If you liked it, please of course hit the like button on it. Subscribe to my channel and sign up for notifications. As I said, there will be a second part of this video coming out where I'll show you how to do even more problems from the calculator section of the SAT, entirely on a graphing calculator, looking at things like solving systems of equalities and also just some general things related to graphing. So some of these problems coming up in part 2 are not going to be specific operations, but they're just going to be showing you in general how you can use the graphing functions, on the calculator to solve problems in their entirety. Otherwise, if you have questions, feel free to leave a comment below. And also one last thing, I mentioned this in the introduction, but in terms of the specific operations on how to do them or the steps to do them, I went through them very quickly in this video. If you would like to see in more detail the specific steps to do these operations, there's another video that'll be linked in the description below. And it's basically primarily for ACT problems, but if you actually watch the operations part, the instructions part, that is exactly the same. You don't have to look at the example problems in that video, but you go to that video, I show you in that video, how to do these operations step by step with the operations also written out on the screen as well. Otherwise, you can also look for a document in the description below, which you can click on and basically download my ACT and SAT calculator operations reference sheet, which again has all the instructions and steps in it as well. All right, so again, hope you enjoyed this video and hope to see you for part 2.